So let's look at some worked examples. Here we have that we should find the remaining angles of triangle ABC, in which A is equals 12.5 centimeter and C is equals 17.7 centimeter and C is equals to 1.1 degrees. Now, before I proceed, I made mention of the fact that in Sine Rule, we use the lowercase letter to represent the sides of the triangle, while the uppercase letter is used to represent the angles of the triangle. So irrespective of the way we have the letters written, we can actually use the unit to denote if we are given the sides or the angles. For example, it is actually difficult to differentiate C, capital C, from small c if it is not well written. So here I have two C's here. One is presented in centimeter and the other in degrees. So we'll take the one in degree as the angle at C, while the one in centimeter as the side of the what? C. Now, another thing to note is this C is 116 degree, which is exactly an obtuse angle. So if you look at this triangle we have here, this is an acute angle, and this is an obtuse angle. So correctly, to be the right thing to do, placing the what? The obtuse angle at this point. So let's say we have this as 116 degree. Call this angle C. Okay? So we can as well call this angle A and call this angle B. Well, you can change this to B while this is C. Now we have the corresponding side of angle C as 17.7 centimeters. So we have side A as well, which is 12.5 centimeters. So this is angle A. The corresponding side is 12.5 centimeters. Now we have to find the remaining angles of triangle ABC. So here we have just an angle given, and two of the angles, that is the angles at A and B respectively, are unknown. So let's try to solve this using the sine rule. So you remember we have to find or use the ratio of two sides to what? Two angles. So here we have angle C, and the side of C is given. We have angle A unknown, while the side of A is known. So that means our sine rule will be written in form of A and C. That is, let's write the rule first. From our sine rule, okay, we have that sine of the angle at A divided by the side of the triangle A is the same as the sine of the angle at C divided by the side C. So let's try to substitute the parameters in the formula. So that means we should have sine A as our unknown divided by the corresponding side of A, which is 12.5 centimeter, equals the angle at C is 116 degrees. That means we write sine 116 degree divided by the corresponding side of C is 17.7 centimeter. Now, our unknown is the angle at A. So let's quickly make sine A the subject. That means sine A will be equals to 125 multiplied by the sine of 116 degrees divided by 17.7 centimeters. So this will give us 12.5 multiplied by, can actually get the sine of 116 degree from your calculator or using the four-figure table. Of course, if you're using the four-figure table, You know that 116 degree is in the second quadrant, and converting 116 to second quadrant, to first quadrant, should give something exactly like 180 minus 116, which is what? 64 degrees. So that's sine 64 degree over 17.7 centimeter. Now, 12.5 times, using a four-figure table or the calculator, we can find the sine of 64 degree. So let's use our calculator. Sine 64 degrees. 64 degrees. That's 0.8443. Let's take that to 4 decimal places. 8443 divided by 17.7 centimeter. So multiplying these two and dividing it by 17.7 should give us 0.5963. That's sine A. So to get the value of our A now, A will be exactly this inverse of our sine. That's arc sine of 0.5963. So the final answer for our angle at A should be 40.7 degree to 1 decimal places. So remember, we have to find the missing angle. So we have angle A calculated, and we are given angle C as 116 degree. So to find the angle at B, we can simply use a very important rule in geometry. It says that the sum of angles in a triangle is 180 degrees. So that rule is still applicable here. Angles in a triangle. Alright, so we have the angle at A now calculated as 40.7 degree. B, that's the angle we are looking for, and the angle at C is 116 degree, all equals 180 degrees. So we have that the angle at B should be 180 degree minus the sum of 116 degree and 40.7 degrees should give us 156.7 degree. So taking the difference of these two, we have our angle B as 23.3 degrees. So we've solved for all the angles in the triangle. Now remember, I said for sine rule, we either have two sides of the triangle given and one angle, or we should have two angles given and the side facing the angle, two sides given one angle, and also two angles with one side. So let's look at another example on the sine rule.